I was scrolling through one of the big AI subreddits the other day, just lurking in the comments, and I kept seeing this phrase pop up over and over again. It's kind of funny, but also a little bit sad.
Oh, let me guess.
People were calling themselves the GPU poor.
Ah, yes. That is a painfully accurate label for about, what, 99% of developers out there right now.
It really is. It just paints this perfect picture of a velvet rope in the world of AI.
Right.
On one side, inside the VIP section, you have the GPU rich, the Metas, the Googles, the OpenAIs, sitting on warehouses full of H100s.
Burning enough electricity to power a small city, probably.
And on the other side, you have the rest of us, the researchers, the students, the garage startups, all trying to fine-tune a model on a gaming laptop that sounds like a jet engine.
Just praying it doesn't melt through the desk before it hits an out-of-memory error.
Exactly.
And look, it's the classic hardware barrier. For a long time, the physics of AI development seemed, well, unchangeable. Training a large language model is just math, sure, but it is heavy, heavy math.
It's all about VRAM, right?
It all comes down to VRAM, video RAM. To store the model weights, the gradients, the optimizer states, it has always been a hardware problem.
But today, we're doing a deep dive into a library that claims the problem isn't actually the hardware at all. They're saying the problem is the software. We're looking at Unsloth.
Which, despite the name, is currently the fastest way to train a model, period.
I have to admit, when I first saw the name Unsloth, I chuckled. It's named after, the slowest animal on Earth.
The irony is pretty thick.
But the claims they're making are speed freak levels of crazy. I was reading through their documentation for this deep dive, and the stats are borderline arrogant in the best way possible.
These certainly aren't modest claims.
No, they aren't talking about a 5% speed boost or a 10% memory saving. They are claiming you can train major models like Llama 3, Mistral, and Gemma 2 times faster.
While using 70% less memory.
70%. And the critical part, the part that usually gets buried in the footnotes of other optimization tools, is that they claim 0% loss in accuracy.
That's the part that always gets me, 0%.
Right, and that is our mission today. We need to strip this down and figure out, is this real or is it snake oil? How do you cut memory usage by that much without deleting data?
And how do you double the speed without cutting corners?
And if Unsloth is really doing this, are we entering an era where I can effectively train a GPT-4 level competitor in my basement?
We might be closer to that reality than you think. But to understand how, we have to look under the hood.
So let's start with the how, because usually in computer science, there's a trade-off. You want speed, you lose accuracy. You want low memory, you lose speed. Unsloth is claiming to break that.
Exactly. We call that a heuristic. You trade precision for performance. But Unsloth is explicit. They use exact methods. The way they do it is by looking at the absolute foundation of how we train AI.
You mean backpropagation?
Specifically, the backpropagation steps.
Okay, let's pause on backpropagation for a second. Just to align our definitions for everyone, that's the learning part of the loop, right?
Correct. Imagine the AI takes a guess at a word. It gets it wrong. Backpropagation is the algorithm that calculates the error, how wrong the guess was, and then propagates that mathematical error backward through the network to update the weights.
And it's the most expensive part of the whole process.
And the most computationally expensive part, by far.
So how does Unsloth make that faster without cheating?
Well, standard libraries like PyTorch are designed to be generalists. PyTorch is incredible, don't get me wrong, but it's a Swiss Army knife. It's designed for computer vision, audio, biology simulations, and text.
And a Swiss Army knife is great for camping, but if you're trying to perform surgery, it's probably not the best tool.
Precisely. The Unsloth team realized that PyTorch creates a lot of overhead. When it does the math for these LLMs, it creates these intermediate tensors. Think of them as temporary data structures or scratch paper.
Okay.
They sit in memory, take up massive space, and they get thrown away milliseconds later.
So it's just digital clutter.
It's massive clutter. Unsloth went in and manually derived the backpropagation steps for LLMs specifically. They did the calculus by hand to find the most efficient path.
That sounds painful.
Extremely. But then they hand-wrote the GPU kernels, the actual low-level instructions that run on the graphics card, using a language called Triton.
Triton is OpenAI's language, right?
It is. It allows for incredibly low-level control over the GPU, almost like writing assembly code.
Ah.
By rewriting these kernels, they eliminated the need for those temporary memory hogs. They aren't changing the math. 2 plus 2 is still 4. They just remove the bureaucratic paperwork that PyTorch usually forces the GPU to fill out before it can do the addition.
So it's efficiency through extreme specialization. They stripped out the general purpose tax.
And that's where the 0% accuracy loss comes from. They are performing the exact same mathematical operations, just in more direct, streamlined path.
This leads me to the hardware conversation, because usually when we talk about custom kernels and Triton, we're talking exclusively about NVIDIA.
Team Green, yeah.
If you were on Team Red with an AMD card, you were usually out of luck.
That used to be the case, and it was a major frustration. Unsloth started strictly on NVIDIA, supporting everything from the older Tesla T4s, which are cheap cloud GPUs, up to the H100s.
But they've expanded now.
They've broken that barrier. They now support AMD and Intel GPUs as well.
That is a significant shift. And what about the operating system? Because I know a lot of people get scared off by the Linux-only requirement.
Also solved. It runs on Linux, standard Windows, and WSL, the Windows subsystem for Linux. They're seemingly trying to remove every excuse you might have for not training your own model.
Okay, I want to get to the aha moment for me, the numbers. Because anyone can run a tiny model. I can run a 1 billion parameter model on my phone, but Unsloth is talking about the big dogs.
They're talking about Llama 3.3. The 70 billion parameter beast.
So just to set the stage here for everyone, usually to fine-tune a 70B model, you're not doing that on one card. You're talking about multiple A100s chained together.
It's an enterprise-grade problem. It's a budget of a small startup problem. If you try to load that on a standard card, your computer just freezes.
But Unsloth's data shows they can fit Llama 3.3 on a single 80 GB GPU.
And not just barely squeezing it in. They reduce the memory usage by over 75% compared to the standard setup.
And the standard setup isn't exactly inefficient, is it? We're comparing it to Hugging Face using Flash Attention 2.
Right. Flash Attention 2 was supposed to be the gold standard. It was the breakthrough of last year. Unsloth has effectively moved the goalposts again.
They've turned a multi-GPU problem into a single card problem.
Basically, yeah.
That is wild. But let's bring it down to the hobbyist level. The person with a gaming PC they bought for Cyberpunk, what can they do?
This is where it gets really fun. Look at the GPT-oss model, 20 billion parameters. That's a very respectable size.
For sure.
Unsloth can run a training run for that on just 14 GB of VRAM.
14 gigabytes, that is nothing in the AI world. You can buy a GeForce RTX 4070 or a used 3090 that clears that easily.
Exactly. It democratizes the mid-range model. You don't need to rely on the tiny 7B models anymore. You can step up to the 20B class on consumer hardware.
But there is another bottleneck we have to talk about. It's not just the size of the model, it's the size of the input, the context length.
Right. How much can the AI read at once before it forgets the beginning of the sentence?
I noticed Unsloth collaborated with Apple on this, which seems like an odd pairing, but interesting.
They did. They implemented a technique called Cut Cross Entropy.
That sounds like a heavy metal band. We are Cut Cross Entropy.
It really does. But in simple terms, standard attention mechanisms in AI, they scale poorly. If you double the amount of text you feed it, the memory requirement doesn't just double, it quadruple.
It's quadratic scaling. It just blows up.
It blows up your memory usage instantly. So Cut Cross Entropy helps flatten that curve.
How much?
Drastically. It linearizes the memory cost for the loss calculation. The results are staggering. For the smaller Llama 3.18B model, native support is usually capped at, 128,000 tokens?
Which is already pretty big.
Right. Unsloth pushed that to 342,000 tokens on a single GPU.
That is massive. That's the difference between reading a novella and reading the entire Lord of the Rings trilogy in one go.
And understanding the connection between page 1 and page 1,000.
Yeah.
And for the 70B model, they support an 89,000 context length on a single card.
Oh, okay.
They claim that is 13 times longer than what competitors can handle on the same hardware.
13 times? That's not an incremental improvement. That's a generational leap.
It changes the utility of the model. A model with a short memory is a chatbot. A model with a massive context window is an analyst. You can feed it entire code bases, massive legal contracts.
Without chopping them up into tiny, incoherent pieces.
Exactly.
I want to pivot to versatility because early on in the open source AI days, optimization tools were often fragile. They worked for Llama too, but if you tried to Mistral, the whole thing crashed.
Oh, yeah.
Unsloth seems to be trying to cover the whole periodic table of AI.
It's extensive. They support the Llama family, obviously.
Yeah.
But also Mistral, Gemma, Qwen, including the new Qwen 3 and DeepSeek.
And it's not just text anymore. I saw mentions of VLM.
No, and this is crucial. They've expanded into vision language models. So you can fine-tune models like Llama 3.2 Vision that can interpret images.
So I could train a model to look at X-rays or analyze satellite imagery on my own machine?
You could. And they've added audio support too. Text-to-speech models like Orpheus and speech-to-text like Whisper.
It's becoming a universal optimization layer. It doesn't care if the data is text, pixels, or sound waves.
If it's a transformer-based model, Unsloth wants to shrink it and speed it up.
Let's talk about the training flavors. We hear LoRa thrown around constantly.
LoRa is the bread and butter. Instead of retraining the whole brain, you just train a tiny adapter layer. Unsloth optimizes that, of course, but they also introduce something called dynamic 4-bit quantization.
Okay, quantization. That usually means making the model smaller by lowering the precision, right? Like going from a high-def photo to a JPEG.
Right. You go from 16-bit numbers to 4-bit numbers. But usually 4-bit quantization is a blunt instrument. You lower the precision of everything across the board.
And the model gets a little brain damage. It gets dumber.
Exactly. It loses nuance. Unsloth's dynamic 4-bit quantization is selective. Think of it like a smart compression algorithm. It figures out which parameters, which neurons, essentially, are crucial for accuracy and keeps them at higher precision.
So it's prioritizing the important bits while compressing the rest.
It is. They claim it maintains accuracy significantly better than standard 4-bit methods. And for the latest hardware, they also support FP8 8-bit floating point training, which is natively faster.
Now, we have to address the elephant in the room, or rather, the reasoning model in the room. Ever since DeepSeek R1 dropped, the narrative has shifted completely toward reinforcement learning.
It really did. Overnight, everyone stopped caring about just generating text and started caring about chain of thought.
They want the model to think before it speaks, and Unsloth is leaning hard into this.
They are. They've integrated support for all the major RL techniques. We're talking PPO, DPO, and the new big one, GRPO.
Can we unpack GRPO for a second? Group Relative Policy Optimization. Why is that the acronym of the month?
So, traditionally, reinforcement learning with human feedback required a separate model, a reward model, that was just as big as the main model.
So you need to double the memory right out of the gate.
Exactly. It was incredibly memory expensive. GRPO changes the math. It allows the model to learn from groups of outputs without needing that massive second model resident in memory. It streamlines the whole process.
And Unsloth's implementation of this allows for what kind of efficiency?
They claim an 80% reduction in VRAM for RL tasks.
80%? That sounds impossible.
It's staggering. They have a notebook example where you can train a reasoning model using GRPO with just 5 GB of VRAM.
5 gigabytes. That runs on a laptop from 2018.
That's the point. This is the democratization part we talked about.
Yeah.
You can take a standard small model like Phi 3 or Llama 8B, and using Unsloth and GRPO, you can train it to reason, like DeepSeek R1.
On your home computer.
Your home computer. It breaks the monopoly. Until now, reasoning felt like magic that only the biggest labs could conjure up because of the compute cost.
Unsloth effectively turned it into a script you can run on a Tuesday evening.
Pretty much.
Speaking of running scripts, ease of use. Because sometimes powerful developer tool translates to absolute nightmare to install.
A valid fear. I've spent weekends fighting with CDA drivers.
Right. But Unsloth has prioritized user experience heavily. They offer free notebooks for Google Colab and Cattle.
So you don't even need to install it locally to try it.
Exactly. You can run it in the cloud for free. Their documentation basically says, select your model, add your dataset, click run.
And they handle the messy stuff in the background.
So once I've trained this masterpiece, am I stuck in their ecosystem?
Not at all. They support full export to the GGUF format, as well as VLLM and SGLang.
GGUF is the format for llama.cgt, right?
Yeah. Which means you can train a model in the cloud using Unsloth, export it, download it, and run it locally on your Mac or PC using tools like LM Studio or Llama.
It closes the loop completely.
You train on the cloud, you deploy on the edge, completely offline.
It's fascinating to see the community reaction to this. I checked their GitHub before we started, 52,000 stars.
That's tier 1 open source territory. That's up there with things like React or TensorFlow.
It validates that this isn't some vaporware or a student project that's going to be abandoned in a month.
It implies trust. When you are messing with the weights of a neural network, you need to trust that the library isn't silently corrupting your data. 52,000 stars suggests the community has vetted this. It works.
So let's zoom out. We have a tool that takes the most expensive, resource-heavy process in modern tech training AI and cuts the cost and hardware requirements by a factor of 2, 3, 4.
It is effectively debloating modern AI. It's proving that we were being incredibly inefficient before. We were throwing compute at the problem because we didn't want to optimize the code.
Unsloth optimized the code.
They did. It feels like we are moving from the mainframe era of AI to the personal computer era.
That's the perfect analogy. In the 70s, you needed a room-sized computer to do a spreadsheet. Then optimization brought it to the desktop.
And Unsloth is doing that for AI training. When you reduce the cost of curiosity, which is what VRAM requirements really are, you speed up innovation.
Right. If an experiment costs $10,000 in cloud credits, you do it once and you play it safe.
But if it costs $10 or just electricity, you do it 1,000 times. You try the crazy ideas. You try to train a model on 17th century poetry just to see what happens.
And that leads me to my big question for you and for the listener. If Unsloth is making it trivial to fine-tune a 20 billion or even 70 billion parameter model on consumer hardware, where does that lead us?
In terms of what?
In terms of the personal AI. Right now, we rely on Claude or ChatGPT. They are generic, brilliant, but generic. They know the internet, but they don't know me.
But if you can fine-tune a model with a 500,000 token context window on your home PC.
Exactly. I can feed it everything. Every email I've sent in the last 10 years, every document on my hard drive, every text message, and I can train it locally. No data leaves my house.
You're talking about a digital twin, a model that speaks like you, knows what you know, and resides entirely on your desk.
That isn't science fiction anymore. With tools like Unsloth, that is a weekend project for a determined developer.
It fundamentally changes the value proposition. The value isn't the base model anymore. Llama is free. The value is your data.
And the ability to bake that data into a brain that you own.
It suggests the moat of the big AI companies might be a lot shallower than they think. If the GPU poor can build models that are 95% as good, but customized specifically for their own lives.
That is a disruption. The power is shifting to the edge.
And apparently it's being carried there by a sloth.
A very, very fast sloth. Thanks for diving in with us. If you've got a GPU collecting dust, maybe it's time to wake it up.
See you next time.